The world of science has one of the most mysterious topics that continues to puzzle scientists from all over the world. Dark matter. What is it? Why is it so important? And how does it affect our universe? Let's get to the bottom of it. Dark matter is a hypothetical form of matter that does not emit or absorb electromagnetic radiation, which makes it invisible to conventional telescopes. However, its existence is inferred from the gravitational effects it has on visible matter, light, and the structure of the universe. An example of such effects would be the motion of stars in galaxies. If only visible matter is considered, stars at the periphery of galaxies should move much slower than those closer to the center. However, observations show that their speeds are almost identical. This means that there must be extra mass in the galaxies that holds the stars together with its gravity. This invisible mass is called dark matter. Scientists believe that dark matter makes up about 27% of the total mass and energy of the universe. By comparison, ordinary matter is only 5%. The rest is accounted for by dark energy, another mysterious force responsible for the accelerated expansion of the universe. But how can we study what we can't see? There are indirect methods. One of them is gravitational lensing. When light from a distant galaxy passes by a massive object, such as a cluster of galaxies, its path is curved. By analyzing these curvatures, scientists can determine the distribution of mass, including the proportion of dark matter. Another way is to observe large structures of the universe, such as galaxy clusters. Computer models show that without dark matter, such structures could not have formed on the observed timescales. The history of the study of dark matter began in 1933, when Swiss astronomer Fritz Zwicky noticed the motion of galaxies in the Coma cluster. He found that the apparent mass of galaxies was not enough to explain their velocities. Zwicky coined the term dark matter to describe the invisible substance that must exist to explain the observations. Later, in the 1970s, American astronomer Vera Rubin and her colleagues confirmed the existence of dark matter by studying the rotation of galaxies. They noticed that stars on the periphery of galaxies moved at the same speed as stars closer to the center, which could not be explained by apparent mass alone. These studies were key to the recognition of dark matter in the scientific community. As for the nature of dark matter, scientists have many hypotheses. One of the most popular is the existence of particles called WIMPs, weakly interacting massive particles. They have virtually no interaction with ordinary matter except for gravity, making them extremely difficult to detect. Experiments are underway in laboratories around the world to search for these particles. For example, in deep underground facilities, where detectors are shielded from cosmic radiation, scientists are trying to record rare interactions between dark matter and atoms. Dark matter also plays a key role in computer simulations that help scientists understand how galaxies and other structures in the universe formed. Without its gravitational influence, current models cannot explain the observable universe. But despite all efforts, dark matter remains one of the biggest mysteries of modern physics. Its discovery or disproof will completely change our understanding of how the universe works. So, dark matter is not just a scientific hypothesis, but the key to unlocking the deepest mysteries of the cosmos. Perhaps one day scientists will find a way to see it in person and understand its nature. In the meantime, this invisible force continues to remind us that the universe is much more complex and surprising than we can imagine.